Substitution is one of the ways that we can find the point of intersection between two equations. Now, the first way that we did this was by graphing. We would graph the two lines, and you could actually see the point where they intersected. But now we have to try this a different way. Substitution is one of the ways, and here are the steps that we use to be able to use substitution. Step 1, solve one of the equations for either x or y. Step 2, substitute that expression in for x or y in the other equation. I'll explain it in just a moment. Number 3, solve for the remaining variable. And step 4, plug that value into both original equations. All right, so here's example 1. Step 1 says solve one equation for x or y. Well, I'm very lucky today because x is we've already solved for x in the first equation. X is equal to y plus 1. I know already, so I don't have to do step 1, that x is equal to this. So, what I'm going to do is step 2. I'm going to substitute the expression. There's my expression. In for x or y. Well, in this case, I'm going to plug it in for x. I know x is equal to y plus 1. So I'm going to take y plus 1 and plug it in for x in the other equation. So here is step 2. 2 times x, which is y, plus 1. Add to that the 3y is equal to 12. Step number 3 is to solve for the remaining variable. The only variable I still have remaining is a y. So I'm going to solve for y. Distribute 2 times y plus 2 times 1 equals, plus 3y equals 12. Here's my equal sign. I need to simplify the left side, so I'm going to add like terms. 2y plus 3y is 5y. Plus 2 equals 12, and that's the 2 that came from right there. Subtract 2 from both sides. 5y is equal to 10. Divide by 5, y is 2. So I did step 3. I solved for the remaining variable. Step 4, I'm going to run out of room. I'll try to find some extra room over here. Plug the value into both original equations. Now I'll get to on the next example, I'll explain the original part. But for right now, we want to plug that value into the original equations. To get an answer, I only have to plug it into one of the equations. But to check my answer, I need to plug it into both and make sure I get the same thing for both equations. So, step 4, I'm going to take the first equation and plug a 2 in for y. X equals 2 plus 1, which is 3. Now, this isn't my answer though. My answer should be, I'll use pink, a point. If you remember, just like with the graphs, I'm looking for that one point of intersection, and that would be 3 for the x and 2 for the y. Now, I plugged that 2 into the first equation to get my answer for x, but I never plugged it into the second equation. Here's where I'm going to check my work. Use the other equation, 2 times x, which is 3, plus 3 times y, which is 2, and see if you get 12. 2 times 3 is 6. 3 times 2 is 6. Does that give me 12?
Juliet Quincy, please come to the front office.
Sorry about that, but I'm going to leave it because I'm done with this one.
Please come to the front office.
So my answer's right. I'm good to go. Let's try one more. Now this one's not going to be as easy because the first equation, let me put that back, the first step is not done for me. I don't have any equation that is solved for x or solved for y. So I'm going to have to do that myself. I'll use the pink. my strong advice is, if you want to figure out how to solve for x or y or which one to solve for, look for an x or a y with a positive 1 in front of it. A negative 1 will do, but let's try for a positive 1 first. I have a positive 1x here. I have a positive 1y here. I can choose either one. But the step does say solve one equation for x or y. So might as well take the first one. Step 1. Solving for x. X minus 3y equals negative 12. To solve for x, I'm going to add 3y to both sides. And those will cancel. I'm left with x equals 3y minus 12. Or negative 12 plus 3y. You can leave it in that order, it's okay. We're not graphing it, so it doesn't have to be in a certain order. There's step 1. Step 2. Substitute the expression. What expression? Well, I know x is equal to this. So I'm going to put this in for x in the other equation. 2 times x, or 3y minus 12, plus y equals 11. Distribute the 2. 6y minus 24 plus y equals 11. Combine like terms. Actually, right now I'm working on step 3, by the way. Step 2 was to substitute it in. Step 3 is to solve for the remaining variable. And my remaining variable is a y in this case. So I have a 6y plus a 1y, which is a 7y. Add 24 to both sides. Oh, I'm going to hold this so it doesn't go off. It's about to fall. Add 24 to both sides. And I get 7y equals 35. Divide by 7. And y is 5. I found one of my answers. All right. Step 4 says to plug that value back into both equations. So I will start with the first equation. X minus 3 times 5 equals negative 12. X minus 15 equals negative 12. Add 15 to both sides. X equals 3. I have my answer. But we should check it. So I'm going to scoot this down a little bit more. And here's where I'm going to check my work. I plugged the 5 into the first equation to get my x. I haven't worked with the second equation, so I'm going to use that one. 2x plus y equals 11. I'll show you. And I'm going to plug in for x a 3 and for y a 5. Oh, I didn't need that parenthesis there. That was silly. 2 times 3 is 6, plus 5. Does that equal 11? Yes. So I have the right answer. All right, and there you go. That's substitution. And your assignment is on Edline under assignments. So if you are missing some of it, you can always check there. All right, thanks.